check. हेलो नमस्ते। आजको भिडियोमा चाहिँ म केही पनि गर्नेवाला त छैन एक्स्ट्रा कुरा। सो आज चाहिँ म यो डिप लर्निङ विथ पाइटर्च सो म्यानिङ पब्लिकेसनको एउटा यो फर्स्ट एडिसन चाहिँ मैले पाएको थिएँ। सो आज चाहिँ यो फर्स्ट एडिसन चाहिँ पढ्नेवाला छु। सो यसमा विभिन्न रहेको छ। आई थिङ्क ओके। सो यसको तीनटा पार्ट चाहिँ देखाइरहेको छ। तीनटा पार्टमा चाहिँ इन्ट्रोडक्सन कोर पाइटर्चहरू देखिएको छ। त्यसपछि पार्ट 2 मा लर्निङ फ्रम इमेज भनेको छ। ओके फर्स्ट वान आई थिङ्क यो रहेको छ होइन। आई थिङ्क यसमा चाहिँ यो सेकेन्ड भर्जनमा चाहिँ बरु यो आई थिङ्क टेन्सर फ्लो होइन ट्रान्सफर्मरहरूको बारेमा थियो जस्तो लाग्थ्यो। यो फर्स्ट एडिसनमा चाहिँ ट्रान्सफर्मर रहेन चाहिँ क्या हो होइन। ओके लेट मी चेक। विथ PyTorch second edition not Python PyTorch torch के फरक छ त यसमा? अभियसली चाहिँ चेन्ज गरेर रहेछ है। यता टेन्सर सो 18वटा च्याप्टर 18वटा च्याप्टरमा यसमा कतिवटा च्याप्टर छ? 15वटा भनेपछि कुन कुन नयाँ थपेको रहेछ त्यसमा? इन्ट्रोडक्सन प्रिटेन्ड मोडल 8वटा। यो त आई थिङ्क योसँग ठिकै सेमै छ रहेछ। सेकेन्ड च्याप्टरमा 9। सो यो दुईवटा चाहिँ इन्ट्रोड्युसिङ यो जेनेरेटिभ मोडल र यो भिजन ट्रान्सफर्मर एन्ड डिफ्युजन मोडल यो दुईवटा चाहिँ थपेको देखेँ। अनि तलपट्टि चाहिँ अप्टिमाइजेसन टु सुपरचार्ज योर पाइटर्च मोडल्स देखेँ होइन। यसो गरौँ पऱ्यो त्यसो भने सो अहिले यो किनेको त छैन $33। सो एमाजोन लेट मी चेक अन एमाजोनमा कति छ? amazon.co.jp एमाजोनमा इङ्ग्लिस deep learning with PyTorch बुकै छैन कि अरू रहेछ। सेकेन्ड एडिसन इङ्ग्लिस एडिसन 5.5 हे यो त्यो पनि किन्डल भर्जन रहेछ। सो यदि पेपरमै चाहियो भने त लगभग 8,836 रुपियाँ। माथि इङ्ग्लिस एडिसन चाहिँ छ। यो इङ्ग्लिस एडिसनको कुन चाहिँ भर्जन हो भन्ने कुरो हो क्या। फर्स्ट भर्जन हो कि सेकेन्ड भर्जन? सो दिस इज अल्सो फर्स्ट भर्जन। सेकेन्ड भर्जन आइसकेको छैन त। सेकेन्ड भर्जन पनि एमाजोनमा छैन। सो आजलाई के गरौँ भन्दाखेरि बेसिकल्ली म फर्स्ट भर्जन नै पढ्दै जान्छु आफ्नो लागि होइन। सो केही त होइन। Okay, let me. Let me live भइरहेछ कि छैन. साउन्ड त आइरहेको रहेछ. Okay. The core PyTorch introducing deep learning and the PyTorch library. So deep learning revolution, PyTorch for deep learning यो विभिन्न रहेछ हैन. सो हेर्दै जान्छौँ. सिंगल लेभल बढाउनु पर्ला जस्तो लाग्यो. ओके, प्रिफेस पनि पढिन. एक्नोलेजमेन्ट पनि पढिन. About this book. Okay. Deep learning with PyTorch does not try to be a reference book, rather it's a conceptual component that will allow you to independently explore more advanced material online. As such, we focus on a subset of a feature offered by PyTorch. The most notable absence is recurrent neural network. Okay, but the same is the true for other part of the PyTorch API. So we should read this book. This book is meant for developers who are aimed to become deep learning practitioners and who want to get acquainted with PyTorch. So we imagine our typical reader to be a computer scientist, data scientist, or software engineer, or an undergrad or later student in related program. Since we don't assume prior knowledge of deep learning, some part of the first half of the book may be repetition of the concept that are already known to experienced practitioners. For those readers, we hope the exposition will provide a slightly different angle to known topics. We expect readers to have basic knowledge of imperative and object-oriented programming. Okay, since the book uses Python, you should be familiar with that syntax and operating system. Knowing how to install Python package and run scripts on the platform of choice is a prerequisite. The readers coming from C++, Java, JavaScript, Ruby, or other language should have an easy time picking it up, but will need to do some catch up outside this book. Similarly, being familiar with NumPy will be useful if not strictly required. We also expect similarity with some basic linear algebra, such as knowing what matrix and vectors are and what a dot product is. So how this book is organized, a roadmap. Or deep learning with PyTorch is organized in three distinct parts. Part 1 covers the foundation, while part 2 works with through and into in project building on basic concept introduced in part 1 and in adding more advanced one. Okay, the short part 3 rounds of a book with a tour of what PyTorch offers for deployment. You will likely notice different voices and graphical styles among the part. Although the book is a result of endless hours of collaborative planning, discussion, and editing, the act of writing and authorizing graphics was still among the parts. Luca was primarily in charge of part 1 and Ilya of part 2. When Thomas came along, he tried to blend the style in part 3. in various section here and there without writing in parts 1 2. Rather than finding a minimum common denominator, we decide to preserve original voices that characterize the part. Following is a breakdown of each part into chapters and a brief description of each part. One, okay. In button we will cover post. Similar to instant patterns observing about out there in the world as well as starting to build our own. We'll cover the PyTorch API and some behind the scene features that make PyTorch the library it is, and training and its classification model. By the end of part 1, we will be ready to tackle a real world project. Okay. Chapter 1 introduces PyTorch as a library and its place in deep learning revolution and touches on what set PyTorch apart from other deep learning frameworks. Chapter 2 knows PyTorch in action by running examples of pre-trained networks. It demonstrates how to download and run models in PyTorch Hub. Chapter 3 introduced the basic building block of PyTorch, the tensor, showing its API and going behind the scene with some implementation details. Okay, chapter 4 demonstrate how different kind of data can be represented as tensor and how deep learning model expects tensors to be saved. Chapter 5 walks through the mechanics of learning through gradient descent and how PyTorch enables it with automatic differentiation. Okay. Chapter 6 shows the process of building and training a neural network for regression in PyTorch using NN optim models. I think यो त मैले भिडियो पनि बनाइसकेको छु हैन. And build on previous chapter how to create a fully connected model for image classification and expand the knowledge of the PyTorch API. Chapter 8 introduces convolutional neural network and touches on more advanced concept of building a concept for building neural network model and the PyTorch implementation of part 2. So part 2, each chapter moves up closer to a comprehensive solution to automatic detection of lung cancer. We will use this difficult problem as motivation to demonstrate the real world approaches needed to solve large scale problems like cancer screening. It is a large project with a focus on clean engineering, troubleshooting, and problem solving. So, chapter 9 describes the end to end strategy we will use for long tumor classification, starting from compound tomography. Okay, the computed tomography. So, CT anyway, computed tomography. Okay. Chapter 10 loads the human notation data along with the image from CT scan and converts the irrelevant information into tensor using standard PyTorch API. Chapter 11 introduces a first classification model that consumes the training data introduced in chapter 10. We train the model and collect basic performance matrices. We also introduce using TensorBoard to monitor training. Okay. Chapter 12 explores and implements standard performance metrics and use those metrics to identify weakness in the training done previously. We then mitigate those flaws with an improved training set that uses data balancing and augmentation. Chapter 13 describes segmentation or pixel to pixel model architecture that we use to produce a heat map of possible nodule location that covers the entire city scan. So this heat map can be used to find modules on CT scan for which we do not have human noted data. So chapter 14 implements the final end-to-end project diagnosis of cancer patient using our new segmentation model followed by classification. So part 3, so chapter 3 is a single chapter on deployment. Chapter 15 provides an overview of how to deploy PyTorch model on a simple web service, embed them in a C++ program or bring them to a mobile phone. Okay. So all the code in this book was written for Python 3.6. I think मेरा 3.9 छ होला हैन. The code for the book is available for download. Okay, download मा छ अरे and GitHub मा छ. GitHub okay. के खाऊं Okay, अहिले बेच्नु भयो GitHub Python deep learning with PyTorch. This I think यो second edition भइसक्यो होला फेरि यो कामहरु चाहिँ गर्दैन थाहा छैन. ओके लेट मी चेक पनि 15 chapter 15 सम्म I think यसको chapter 15 छ. ओके यो मान्छे सेम रहेछ. ओके के एक्स्ट्रा गर्नु पर्दैन. सो हेलो ले त गर्नु पर्दैन. ओके matplot lib inline from matplotlib import pyplot. I think torch install छ, matplot छ, numpy पनि छ. So हार्डवेयर भएन भने यदि मेरोमा गएन भने पनि चलिन्छ हामीसँग. गुगल कोल्याबमा पनि रन गर्न सकिन्छ. Okay, Silicon Valley with role ranging from software engineer making enterprise networking application to CTO. He's working on machine learning. Okay, Arco writer Luca Antiga. Organized research in biology. Spent the last decade as a co-founder and CTO of an AI engineering company. He has contributed several open source projects, including PyTorch. Okay, Luca Antiga. Okay, I think Meta ma gera लेख्ने मान्छे यही हो. Let me check. Colors paper और के छ यो मान्छेको. Time style. Okay, 2019 मा यो मान्छे थियो लेख्दाखेरि PyTorch लेख्दा भर्जन 1 आउँदाखेरि. Okay, Lightning AI चाहिँ I think AMD ले गरेको हैन र भने. Lightning AI त I think AMD ले आफ्नो PyTorch रन गर्नलाई चाहिँ लेखे जस्तो लागिरहेको थियो. Lightning AI. Okay. Layout. Maybe wrong this way. 2015 by Lightning founder William Falcon while working on computational neuroscience research at Columbia University scaling generative generative adversarial network GAN autoencoder in the context of neural decoding working under Lampeninski. Okay, mistake bhayo क्या. I think AMD ले PyTorch ले त कुडा युज गर्छ. AMD ले के हो सर युज गर्छ. AMD ले ROM PyTorch. Okay, ROM मा देखाइन रहेछ त. Okay, I think ROM हुनुपर्ने हो. ROM is not available on Windows. Linux and Mac मा गयो भने ROM चाहिँ छ रहेछ क्या. Okay, AMD ले के सपोर्ट गर्छ. Does AMD support PyTorch training? PyTorch supports on RDNA 3 GPUs via the ROC platform. Okay. AMD extends support for PyTorch machine learning deployment on select RDNA. Hmm. Hmm. रोके मुके AMD ले चाहिँ गरेर त विन्डोजमा यो सपोर्टै हटाएछ त फेरि वाइ AMD वाइ ओके धेरै बहन भएन लेट्स गो ब्याक टु ओके त्यस पछाडि यो भयो एन्टी आगारले लेखायो ओके त्यस पछाडि थोमस बिएमएन भनेको फेरि ओके and consultant based in Munich, Germany, and a PyTorch code developer with a PhD in mathematics. He is not scared by theory, but he is truly practical when applying it to computing challenges. Okay. About cover illustration गएन त्यसपछि सिधै I think part 1 को core PyTorch बाट पढ्न सुरु गर्छु and this is where we will take our first step with PyTorch, gaining the fundamental skills needed to understand its anatomy and find out the mechanics of PyTorch objects. In chapter 1 we will make our first contact with PyTorch, understand what it is and what problems it solves and how it relates to the deep learning frameworks. Chapter 2 will take us okay कपडा सुकाउनु पर्ने थियो यार बिर्सिरहेको same problems can be cracked in a much smarter way to using a convolutional neural network. By the end of part 1, we will have what it takes to tackle the real world problem with PyTorch in part 2. Okay. So introducing deep learning, the PyTorch library. So how deep learning changes our approach to machine learning. Understand why PyTorch is a good fit for deep learning. Examining a typical deep learning project, the hardware you will need to follow along the examples. Okay. The, the poorly defined term artificial intelligence covers a set of disciplines that have been subjected to a tremendous pronunciation पनि सबै बिग्रिएछ tremendous amount of research, scrutiny, confusion, fantastical hype, and sci-fi fear, fear, fear mongering. Okay, the reality is, of course, far more sanguine. It will be disingenuous to assert that today's machines are learning to think in any human sense of the word. Rather, we have discovered a general class of algorithms that are able to approximate complicated nonlinear process very effectively, which we can use to automate tasks that were previously limited to humans. For example, at okay tools to transform.com, or language model called GPT-2 can generate coherent paragraphs of text one word at a time when we feed it. Okay, let me check here the alumna is the के देखिरहेको छु केही नआइपुग्दा बुझिएला नि त डिस्कन्टिन्युड जब मैले हेर्दै थिएँ डिस्कन्टिन्युड भइसकेको रहेछ ब्याड okay all language model okay can generate when you feed it in the very paragraph it produces the following. Next we are going to feed in a list of phrases from a corpus of email addresses and see if the program can parse the list as sentence. Again, this is much more complicated and far more complex than the search at the beginning of this course, but hopefully helps us understand the basic of constructing sentence structure in various programming language. That's remarkably coherent for a machine, even if there isn't a well-defined thesis behind the rambling. Even more impressively, the ability to perform this formerly human-only task is acquired through examples rather than encoded by a human as a set of handicraft rules. Now we are learning that intelligence is a notion we often conflate with self-awareness. Self-awareness is definitely not required to successfully carry out those kind of tasks. In the end, the question of computer intelligence might not even be important. Okay, it's got the okay. This is found that the question of what whether machines could think was about as relevant as the question of whether submarines can swim. The general class of algorithm we are talking about falls under the AI subcategory of deep learning, which deals with training mathematical entities named deep neural networks by presenting instructive examples. Deep learning uses large amount of data to approximate complex functions whose input and outputs are far apart, like an input image and output, a line of text describing the input, or a written script as input, and natural sounding voice reciting the script as output, or even more simply associating an image of a golden retriever with a flag that tells us as a golden retriever is present. This kind of capability allows us to create program with functionality that was until very recently exclusively the domain of human beings. The okay human beings and the deep learning revolution. To appreciate the paradigm shift ensured in by this deep learning approach, let's take a step back for a bit of perspective. Until the last decade, the broader class of systems that fall under the name label machine learning relied heavily on feature engineering, feature transformation on input data that facilitate a downstream algorithm like classifier to produce correct outcomes on new data. Feature engineering consists of coming up with the right transformation so that the downstream algorithm can solve the task. For instance, in order to tell ones from zeros in image of handwritten digit, we will come up with a set of filters to estimate the direction of edge over the image, and then train a classifier to predict the correct digit given a distribution of edge direction. As a result, feature could be the number of enclosed holes as seen in the zeros and the edge and the particular loopy 2. Okay, the threads, the computing science. Mhm. Deep learning, on the other hand, deals with finding such representation automatically from new raw data in order to successfully perform a task. In the one versus zeros example, filters will be refined during training by iteratively looking at pairs of example and target levels. This is not to say that feature engineering has no place with deep learning. We often need to inject some form of prior knowledge in our learning system. However, the ability of a neural network to ingest data and extract useful representation on the basis of example is what makes deep learning so powerful. The focus of deep learning practitioners is not so much on handicrafting those representation, but on operating on a mathematical entity so that it discovers representation from a training data autonomously. Often these automatically created features are better than those that are handicrafted. As with many disruptive technologies, this fact has led to change in perspective. On the left side of figure 1.1, we see a practitioner busy defining the engineering features and feeding them into a new learning algorithm. The results on the task will be as good as features and the practitioner engineers. On the right side, with deep learning, the raw data is fed into an algorithm that extracts hierarchical features automatically guided by the optimization of its own performance on the task. The result will be as good as the ability of the practitioner to drive the algorithm towards its goal. Okay, data, deep learning machine, okay, representation outcome. Patito. Setup data, this is a handcrafted features, learning algorithm, automated. Okay. Hmm. So starting from the right side in figure one, we have already get a glimpse of what we need to execute successful deep learning. We need a way to ingest whatever data we have at hand. We somehow need to define the deep learning machine. We must have an automated way law training to obtain. Okay. To obtain useful representation and make the machine produce desired outputs. This leaves us with taking a closer look at this training things we keep talking about. During training, we use a criterion or real value function of model outputs and reference data to provide a numerical score for a discrepancy between the desired and the actual output of our model. By convention, a lower score is typically better. The training consists of driving the criterion towards lower and lower score by incrementally modifying our deep learning machine until it achieves low scores even on data not seen during training. PyTorch for deep learning is PyTorch is a library for Python programs that facilitates building deep learning projects. It emphasizes flexibility and allows deep learning models to be expressed in idiomatic Python. This approachability and the ease of use found earlier adopters in the research community, and in the years since its first release, it has grown into one of the most prominent deep learning tools across a broad region of applications. It's Python does for programming. PyTorch provide an excellent introduction to deep learning. At the same time, PyTorch have been proven to be fully qualified for use in professional context for real world approval work. We believe that PyTorch clear syntax, streamlined API, and easy debugging make it an excellent choice for introducing deep learning. We highly recommend studying PyTorch for your first deep learning library. Whether it's ought to be the last deep learning library you learn is a decision we leave up to you. At its core, the deep learning machine in Figure 1.1 is a rather complex mathematical function mapping inputs to an outputs to facilitate expressing this function. PyTorch provides a core data structure of the tensor, which is multi-dimensional array that shares many similarities with NumPy arrays. Along that foundation, PyTorch comes with features to perform accelerated mathematical operation on dedicated hardware, which makes it convenient to design neural networks, architectures, and train them on individual machines or parallel computing resources. Okay, this book is intended as a starting point for software engineer, data scientists, and motivated students fluent in Python to become comfortable using PyTorch to build deep learning projects. We want this book to be as accessible as useful as possible, and we expect that you will be able to take concept in this book and apply them to other domains. To that end, we use a hand-on approach and encourage you to keep your computer at ready so that you can play with the examples and take them a step further. By the time we are going through this book, we expect you to be able to take a data source and build out deep learning projects with it, supported by the excellent official documentation. Although we stress the practical aspect of building deep learning system in the PyTorch, we believe that providing an accessible introduction to a foundational deep learning tool is more than just a way to facilitate the acquisition of new technical skills. Okay, it is a step towards equipping a new generation of scientists, engineers, and practitioners from a wide range of disciplines with working knowledge that will be backbone of many software projects during the decade to come. In order to get the most out of this, you will need to think okay, catch some experience programming in Python. We are not going to pull any punches on that one. You will need to be up on Python data types, okay, classes, floating points, numbers, and the like. The willingness to dive in and get your hand dirty will be starting from the basics and building up for working knowledge, and it will be much easier for you to learn if you follow along with us. Deep learning with PyTorch is organized in three distinct parts. Part one covers the foundation, explaining in details the facilities PyTorch offers to put the skills of deep learning into action with code. Part two also through an end-to-end projects involving medical imaging, finding the classifying tumor in CT scan, building on the basic concept introduced in part one, and the adding more advanced topic. The short part 3 rounds of the book with her tour of what PyTorch offers for deploying deep learning model to production. So deep learning is a huge space. In this book, we will be covering a tiny part of that space, specifically using PyTorch for smaller scope classification and segmentation projects with image processing of 2D and 3D dataset used for most of the motivating examples. This book focus on practical PyTorch with the aim of covering enough ground to allow you to solve real world machine learning problems such as in vision with deep learning or explore new models as they pop up in research literature. Most of it all the latest publication related to deep learning research learning research can be found in the XP okay repository. Research, artificial intelligence, computer vision and pattern recognition, computer society, neural network, machine learning, machine learning, फ्राइडे भनेको हिजोसँग अपलोड गर्दाखेरि नयाँ भनेको यिनीहरू आएको छ। ओके, एक्सप्लोरिङ लर्निङ डाइनामिक्स इन कन्सेप्ट इज एफिसिएन्ट ओल्ड मेडल्स एन्ड कन्टेक्स्ट यत्रो कसरी कसरी कभर गर्दै जाने हो। जम्प स्टार्टिङ भेन्डर्स विथ एलएलएम जेनेरेटिभ प्रायर नलेज, स्टेटिस्टिक कन्सेप्ट बोटलनेक मोडल्स। ओके, फेरि हेरौँ न पछि। Why PyTorch? As we said, deep learning allows us to carry out a various wide range of complicated tasks like machine translation, planning strategy game, or identifying objects in cluster. In by exposing our models to illustrative examples in order to do so in practice, we need tools that are flexible so they can be adapted to such a wide range of problems and efficient to allow training to occur over large amount of data in reasonable times, and we need the trained model to perform correctly in the presence of variability in the inputs. Let's take a look at some of the reasons we decided to use PyTorch. PyTorch is easy to recommend because of its simplicity. Many researchers and practical practitioners find it easy to learn, use, extend, and debug. It's Pythonic, and while like any complicated domains, it has caveats and best practices. Using the library generally feels familiar to developers who have used Python previously. More concretely, programming the deep learning machine is very naturally in PyTorch. PyTorch gives us some data types, the tensor to whole numbers, vectors, matrix, or array in general. In addition, it provides function for operating on them. We can program with them incrementally and if we want interactively, just like we are used to from Python. If you know NumPy, this will be very familiar, but PyTorch offers two things that make it particularly relevant for deep learning. First, it provides accelerated computation using graphical processing unit GPUs. Okay, Okay. 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 But PyTorch. Mm-hmm. PyTorch is easy to recommend because of simplicity. Many researchers and practitioners find it easy to learn, use extended and debug it. Pythonic and like complicated domains, it is a very caveats and best practices. Using the library generally feels similar to developers who have used Python previously. More concretely programming, concretely programming the deep learning machine is very natural in PyTorch. PyTorch gives us a data type, the times are to hold numbers, vector, matrices, or array in general. In addition, it provides functions for operating on them. We can program with them incrementally, and if we want interactively, just like we are used to from Python. So, okay, if you know NumPy, this will be very familiar. Yes, but PyTorch offers two things that is okay. First, you can it provides accelerated computation using graphical processing unit, often yielding speedups in the range of 50x over doing the same calculation on a CPU. Okay. Second, PyTorch provides facility that supports numerical optimization on generic mathematical expression, which deep learning uses for training. Note that both features are useful for scientific computing in general, not exclusively for deep learning. In fact, we can safely characterize PyTorch as a high performance library with optimization support for scientific computing in Python. Okay. Our design driver for Python is expressivity, allowing a developer to implement complicated models without undue complexity being imposed by the library. It is not a framework. PyTorch arguably offers one of the most seamless translations of ideas into Python code in deep learning landscape. For this reason, PyTorch has seen widespread adoption in research, as witnessed by the high citation counts in international conferences. Okay, PyTorch also have a compelling history for the transition from research and development into production. While it was initially focused on research workflows, PyTorch has been equipped with a high performance C++ runtime. Okay, that can be used to deploy models for inference without relying on Python, and can be used for designing and training models in C++. It has also grown bindings to other language and in interface for deploying to mobile devices. These features allow us to take advantage of PyTorch flexibility, and at the same time our application where a full Python runtime will be hard to get or would impose expensive overhead. Of course, claims of ease of use and high performance are trivial to make. We hope that by the time you are in thick of this book, you are agree with us that our claims were all founded. Okay. The deep learning competitive landscape, while all analogies are flawed, it seems that the release of PyTorch 0.1 in January 2017 marked the transition from a Cambrian explosion like proliferation of deep learning libraries, wrappers, and data exchange format into the era of consolidation and unification. Not the deep learning landscape has been moving so quietly lately that by the time you read this print, it will be likely be out of date. Okay, at least so. If you are unfamiliar with some of the libraries mentioned here, that's fine. At the time of PyTorch's first beta release, Theano, TensorFlow were the premier low-level libraries working with a model that had the user define a convolutional graph. Who then executed Lasagne and Keras were high-level wrappers around Theano with Keras wrapping TensorFlow and CNTK as well. Cafe, Chena, Dynator, the Lua-based precursor to PyTorch. MXNet, CNTK, DLJ4, and other field various niches in the ecosystem. Okay. In the roughly 2 years that followed, the landscape changed drastically. The community largely consolidated behind either PyTorch or TensorFlow. मन पहिला TensorFlow मा थिएँ, त्यसपछि अहिले भर्खर PyTorchमा चेन्ज हुँदैछु, चेन्ज भइरहेको छु, चेन्ज भएँ होइन, विथ द integration of other libraries. So except for these feeling specific niches, in a nutshell, one of the most first deep learning frameworks has is active deployment. Okay, TensorFlow consume Keras entirely, promoting it as a first class API. फ्रान्चेस कोलिस भनेर लेखेँ होइन हो उसको चाहिँ मैले यो पाइथन डिप लर्निङ विथ डिप लर्निङ विथ पाइथन लर्निङ आई थिङ्क यो मैले बुक 2017-18 पढेको थिएँ होला सो ओके फ्रान्चोइस सो हि इज द राइटर अफ केराज उसैले लेख्यो केराज होइन पछि टेन्सर फ्लोले चाहिँ के भनौँ भन्दाखेरि एज अ फर्स्ट क्लास एपिआई चाहिँ दियो मतलब टेन्सर फ्लोमा चाहिँ केराजलाई चाहिँ इम्प्लिमेन्ट गर्यो कम्प्लिटली अहिले चाहिँ केराज 3.0ले चाहिँ आई थिङ्क टेन्सर फ्लो त्यस पछाडि ज्याक्सलाई पाइटर्च सबै सपोर्ट गर्छ अचेल चाहिँ इन्ट्रेस्टिङ छ अहिले चाहिँ यस Okay, provided any immediate education eager mode that is somewhat similar to how PyTorch approaches competition. Okay, released on TensorFlow 2.0 with eager mode by default. Okay, JAX library by Google that was developed independently from TensorFlow has started gaining traction as a NumPy equivalent with GPU, AutoGrad and JIT capabilities. Okay, PyTorch consume Cafe2 for its backend, replace most of the low-level code released from the Luna based Torch project and added support for Onyx, vendor neutral model description and actions format, added a delayed execution graph mode runtime called Torch script, release version 1.0. Okay, replace CNTK and Chainer as the framework of choice by their respective corporate sponsors. So TensorFlow has a robust pipeline to production and extensive industry-wide community and massive mindshare. PyTorch has made huge inroad with the research and teaching communities. Thanks to it ease of use and has picked up momentum since the researchers and graduates train students and move to industry. It has also built up streams in terms of production solution. Interestingly, with the advent of TorchScript and eager mode, both PyTorch and TensorFlow have seen their feature set starts to converge with the others. Though the presentation of these features and the overall experience is still quite different between the two. An overview. We can best do this by looking at what are deep learning projects need from PyTorch. First, PyTorch has a Py as in Python, but there is a lot of non-Python code in it. Okay, actually for performance reason, most of the PyTorch is written in C++ and CUDA. Or C++ like language from NVIDIA that can be compiled to run with massive parallelism on GPUs. There are ways to run PyTorch directly from C++, and we will look into this on chapter 15. One of the more motivation for capability is to provide a reliable strategy for deploying models in production. However, most of the time we will interact with PyTorch from Python, building models, training them, and using the train model to solve actual problems. Indeed, the Python API is where PyTorch shines in terms of usability and interaction with the wider Python ecosystem. Let's take a peek at the mental model of what PyTorch is. So as we already touched on, at its core, PyTorch is a library that provides multi-dimensional arrays or tensor in PyTorch parlance. We'll go in detail on those on chapter 3. Okay, and the extensive library of operation on them provided by the torch module. Both tensor and the operation on them can be used on the CPU and or the GPU. Moving computation from CPU to the GPU in Python doesn't require more than an additional function called R2. The second core thing that PyTorch provides is the ability of tensors to keep track of the solo operation perform on them and to analytically compute derivatives of an output or completion with respect to any of its inputs. This is used for numerical optimization, and it is provided natively by Tensor by virtue of dispatching through PyTorch AutoGrad engine under the hood. By having Tensor and the AutoGrad enabled Tensor standard library, PyTorch can be used for physics, rendering, optimization, simulation, modeling, and more. We are very likely to see PyTorch used in creative ways throughout the spectrum of scientific application. But PyTorch is first and foremost a deep learning library, and as such, it provides all the building blocks needed to build neural networks and train them. Figure 1.2 shows a standard setup that loads data, trains a model, and then deploys that model to production. The core PyTorch models for building neural networks are located in torch.nn. Okay, torch.nn को module में which provides common neural network layers and other architecture components. Fully connected layers, convolution layers, activation function, loss function can all be found there here. Okay, we'll go in more detail with all that means as we go through the rest of this book. These components can be used to build and initialize the on-train model as we see in center of figure 1.2. Okay, this is one figure 1.2. Okay, in order to train our model, we need a few additional things: a source of training data or optimizer to adapt the model to the training data, and the model and data to the hardware that will actually be performing the calculation needed for training the model. An overview of now how PyTorch supports deep learning projects. Okay, data source for the sample tensor magayo. Okay, this was a batch tensor. This is training loop, train model. Okay, production ONXX, JID, touch script, cloud ma production server, distributed training. Okay, on the left figure 1.2, we can say quite a bit of data processing is needed before the training data even reaches our model. First, we need to physically get the data, most often from some sort of the storage as the data source. Then we need to convert each sample from our data into something PyTorch can actually handle tensors. This bridge between our custom data in whether format it might be and a standardized PyTorch tensor in the dataset class. PyTorch provides a provides interceptors as it's widely different from one problem to another. We will have to implement this data sourcing ourselves. We will look in details at how to represent various types of data we might want to work with as tensor in chapter 4. Okay, all large or as data storage is often slow, it particularly due to access latency. We want to parallelize data loading, but as many things Python is well loved for do not include easy, efficient parallel processing. We will need multiple processes to load our data in order to assemble them into batches tensor that encompass several examples. This is rather elaborate, but as it is also relatively generic, PyTorch readily provides all the magic in the data loader class. Okay, it it instance can spawn child process to load data from a data set in the background. Okay, so that is ready and waiting for training loop. As soon as the loop can use it, okay, we will meet and use data set and the data loader in chapter 7. Okay, with the mechanism for getting batches of sample in place, we can turn into the training loop itself as a center of figure 1.2. Typically, the training loop is implemented as a standard Python for loop. Um, in the simplest case, the model runs the required calculation on the logical CPU or as a single CPU, and once the training loop has the data, competition can start immediately. Such as this will be basically set up to will be our basic will be your basic setup too, and it's one we will assume on this book. At this switch in the training loop, we evaluate our models on the samples we got. I think we are 12 मा छौँ होइन. I think you why PyTorch. I think an overview of how PyTorch supports some handle. I think at each step in training loop, we evaluate our model on the samples we got from data loader. We then compare the outputs of our model in the desired output, the target using some criterion or loss function or cost function. The it offers the confidence from which to build our model. PyTorch also has a variety of loss function at our disposal. They too are provided in torch.nn. After we have compared our actual outputs to the ideal with the loss function, we need to push the model a little to move its outputs to better resemble the target. Okay. As mentioned earlier, this is where the PyTorch AutoGrad engine come in, but we also need an optimizer doing the update, and this is what PyTorch offers us is in torch.optimizer. Torch.optimizer. We will start looking at training loops with loss function and optimizers in chapter 5, and then hone our skill in chapter 6 through 8 before embarking on the big project in part 2. Okay. It increasingly common to use some more collaborative hardware like multiple GPUs or multiple machines that combine contribute the research to training a large model as soon as seen in the large center of figure 1.2. In this case, torch.nn.parallel dot distributed data parallel or and the torch.distributed sub module can be employed to use the additional hardware. Okay. The training loop can be the most exciting, it most time consuming part of the deep learning project. Okay. At the time we are rewarded with a model whose parameters have been optimized on our ranks. The train model represented to the right of the training loop in the figure. Having a model to solve a task is great, but in order for it to be useful, we must put it where the work is needed. This deployment part of the process depicted. Or we expect it to the as mentioned earlier, PyTorch defaults an immediate execution model. Involving PyTorch is executed by the Python interpreter. The corresponding operation is immediately carried out by underlying C++ or CUDA implementation. As more instruction operate on tensor, more operation are executed by the backend implementation. Okay. PyTorch also provide a way to compile model ahead of time through torch script. Okay. Using torch script, PyTorch can serialize a model into a set of instructions that can be invoked individually from Python. This is from C++ program on mobile device. We can think about it as a virtual machine with a limited instruction set, specific tensor operation. This allows us to export our model either as torch script to be used with the PyTorch runtime or in a standard format called Next. These features are at the basis of the production deployment capabilities of PyTorch. We'll cover this in chapter 15. Okay. So hardware and software requirement. Using Jupyter notebook. I think yeah, okay. This book will require coding and running tasks that involves heavily numeric computing, such as multiplication of large number of matrices. As it turns out, running a pretend model on new data is within the capabilities of operation laptop or or personal computer. Even taking a pretend network and retaining a small portion of it to specialize it on a new data set. Yeah, okay. Okay, yeah, even state model and function of it visualizing doesn't necessarily require visualize hardware. You can follow along with everything we do it in part one of this book using a standard personal computer or laptop. However, we anticipated that completing a full training run for the more advanced examples in part 2 will require a CUDA enabled GPU. The default parameters used in part 2 assumes as CPU GPU with 8 GB of RAM. Okay, we suggest NVIDIA GTX 1070 or better, but those can be adjusted if your hardware has less RAM available. To be clear, such hardware is not mandatory if you are willing to wait. But running on a GPU cuts training time by at least in order of magnitude. It's 40 to 50% faster. Okay. Taken individually, the operation required to compute parameters updates are fast, from fractions of a second to a few seconds on modern hardware like a typical laptop CPU. This is that training involves running this operation over and over many times, incrementally updating the network parameters to minimize the training error. Moderately large number networks can take hours to take 2 days to train from scratch on large real-world dataset on orchestration equipped with a good CPU. That time can be reduced by using multiple GPUs on the same machine, and even further on cluster of machines equipped with multiple GPUs. These setups are less prohibitive to assess than its own, thanks to the offerings of cloud computing providers. DAW and Bench is an interesting initiative from Eastern University aimed at providing benchmark on training time and cloud computing costs related to common deep learning tasks on publicly available dataset. So if there is a GPU around by the time you reach part 2, then great. Otherwise, we suggest taking out the offerings from the various cloud platforms, many of which offers GPU enabled Jupyter notebook with PyTorch pre-installed, often via free quota. Google Collaboratory. Collab Google is a great place to start. The last considered is the operating system OS. The PyTorch has supported Linux, Mac OS from its first release, and it can Windows support in 2018. Since current Apple laptop do not include CPUs that support CUDA, the pre-compiled Mac OS packages for PyTorch are CPU only. Throughout the book, we will try to avoid assuming you are running a particular OS, although some of the scripts in part 2 are shown as it's running from a base prompt under Linux. These script command lines should convert to a Windows compatible form readily. For convenience, code will be listed as it if running from a Jupyter notebook when possible. For installation, please see us get started. यो हेर्नु पर्दैन. We suggest that Windows users हामीले किन पहिले गरिसकेका छौँ. Other operating system like Linux हेर्नु पर्दैन. Part 2 has some non-retrievable download हेर्नु पर्दैन. Using Jupyter notebook, we are going to assume you have installed PyTorch and other dependency and have verified working. Earlier we touched on possibilities for following along with the code in the book. We are going to making use of Jupyter notebook for our code example code. The Jupyter notebook shows itself as a page in a browser through which we can run code interactively. The code is evaluated by a kernel of process running on a server that is ready to receive code to execute and send back the result, which are then rendered inline on the page. Of network maintains the state of the kernel, like variables defined during the evaluations. A notebook maintains the state of the kernel, like variables defined during the evaluation of code in memory until it's terminated or restarted. The fundamental unit with which we interact with the notebook is a cell, a box on the page where we can type code and have the kernel evaluated through the menu item or by pressing shift enter. We can add multiple cells in a codebook, and the new cell will see the variables we created in the earlier cells. The value returned by the last line of a cell will be printed right below the cell after execution, and the same goes for the plot. By mixing source code, result of evaluations, and markdown formatted text cells, we can generate beautiful interactive documents. You can read everything about Jupyter Notebook on the project title showcase.org. At this point, you need to start the notebook server from the root directory of the code with checkout from GitHub. You can exactly starting okay, how exactly starting the server looks depends on the details of your OS and how and where you install Jupyter. If you have questions, feel free up to ask in the books forum. Okay. Note Jupyter Notebook are a powerful tools for expressing and investigating ideas through Note. While we think that they make for a good fit for our use case with this book, we are not okay. They are not for everyone. We would argue that it is important on to focus on removing frictions and minimizing cognitive overheads, and that is going to be different for everyone. Use what you like during your experimenting experimentation with PyTorch. Working code for this listing. Okay, Marco is so exercise. Start Python to get the interactive prompt. For the summary, deep learning models automatically launched associated inputs and desired outputs. For example, so okay, libraries like PyTorch allows you to build and train neural networks models efficiently. PyTorch minimizes cognitive overhead while focusing on flexibility and speed. It also defaults to immediate execution for operation. Torch script allows us to precompile models and invoke them not only from Python but also from C++ program on model device. Okay. Since the release of PyTorch in 2000, early 2017, the deep learning tooling ecosystem has consolidated significantly. PyTorch provides a number of utility libraries to facilitate deep learning projects. So pretend model as well. Captioning model that can produce text. We close our first chapter, promising to unveil amazing things in the chapter. The time is time to deliver. Computer vision is certainly one of the fields that have been most motivated by the advent of deep learning for a variety of reasons. We need the need to classify or interpret the content of natural language, natural images existed. Every large data set become available, and new construct such as convolution layer were invented and could be run quickly on GPUs with unprecedented accuracy. All of these factors combined with the internet designs desire to understand pictures taken by millions of users with their mobile devices and manage unsaid giants platform quite the perfect storm. We are going to learn how to use the work of the best researchers in the field by downloading and running very interesting models that have already been trained on open large scale dataset. We can think of a pretend neural network as similar to a program that takes input and generates output. The behavior of such program is detected by the architecture of the neural network and by the examples it shows during training in terms of desired input output pairs or desired properties that the output should satisfy. Using an old the cell model can be quick to jumpstart on deep learning projects since it draws on expertise from the researchers who designed the model as well as the computation time that went into training the weights. In this chapter, we will explore the three popular pretend model: a model that can label an image according to the context, another that can fabricate a new image from a real image, and a model that can describe the content of an image using from a English sentence. We learn how to load and run these pretend models. and we'll introduce PyTorch Hub, a set of tools through which PyTorch models like the pretends ones we will discover can be easily made available through a uniform interface. Along the way, we'll discuss data source, define terminology like label, and attend the zero rodeo. If you are coming to PyTorch from another deep learning framework, you will rather jump right into learning the nodes and the rules of PyTorch. You can get away with skipping to the next chapter. The things we will cover in this chapter are more fun than foundational and are wow somehow. I think usually jump गर्नुपर्छ क्या chapter 3 मा because I know अलिअलि बेसिक थाहा छ. Okay, that's nonsense. They are not important, but if you are worked with pretend models in other deep learning models, then you already know how powerful our tools they can be. Obviously, TensorFlow LXNet, विभिन्न रेसनेटहरू युज गरिसकेका थिएँ अनि if you are already familiar with the generative adversarial network, ज्ञान I think ज्ञान बनाएको छु मैले केराज चाहिँ युज गर्न. You don't need to explain it. You don't need us to explain it to you. We hope you keep reading through though since this chapter had some important skills on the phone. Learning how to run a pretend model using PyTorch is a useful skill. Full stop. It's especially useful if the model has been trained on a large data set. We will need to get accustomed to the mechanics of obtaining and running a neural network on real old data and then visualizing and evaluating these outputs whether we train it or not. Okay, a pretend network a pretend network that recognizes the subject of an object as the first for into deep learning. We will run our state of the art deep neural network that was pretend on object recognition task. That there are many pretend models networks that can be accessed through source code repository. It is common for researchers to publish their source code along with their paper and often the code comes with weight that were obtained by training a model on a reference dataset. Using one of these models could enable us, for example, equip our next web server service with image recognition ability with very little effort. The pretend network we will explore here are trained on the subset of ImageNet dataset. Okay, ImageNet. Okay, ImageNet is a very large dataset of over 14 million images maintained by Stanford University. All the images are labeled with a hierarchy of nouns that come from the coordinate subset. Okay, Princeton Go, which is in turn a large lexical database of an English language. The ImageNet dataset, like several other public datasets, it's The ImageNet, like several other public database, okay, dataset, and has its original in academic competition. Competition have traditional, traditional meaning. Researchers at institutions and companies regularly challenge each other. Among others, the ImageNet large-scale visual recognition challenge has gained popularity since its inception 2010. The particular competition is based on a few tasks which can vary each year, such as image classification, telling what object categories the image contains, object recognition, identifying object position in image, object detection, identifying and labeling object in image, scene classification, classifying a situation in an image, and scene parsing, okay, segmenting an image into region associated with semantic categories such as cow, house, cheese, hat. In the in the particular in particular, the image classification task consists of taking an input image and producing a list of 5 labels out of 1,000 total categories ranked by confidence, describing the content of the image. Okay, 1.5 घन्टा online छ लाइभ बसेको नि ओके The training set of ILS-BRC consists of 1.2 million images labeled with one of the 1,000 nouns. For example, dog referred to as a class of an image. In this sense, we will use the term label and class interchangeably. We can take a peek at images from ImageNet in figure 2.1. Okay, के हो cat हो bug हो dog capsicum dog cat okay यस्तो के होला त्यतिजना स्याम्पल डग इमेजलाई राख्यो रिसाइज गर्यो सेन्टर गर्यो नर्मलाइज गर्यो फरवर्ड पास गरिदियो प्रिटेन्ड वेट्समा भइहाल्यो त्यसपछि स्कोर गर्ने 1000 स्कोर्समा एउटा म्याक्स स्कोर लिने त्यही नै हुन्छ we are going to end up being able to use our own images and feed them into our pretend model as pictured in 2.2. This will result in the list of predicted labels that for that image, which we can then examine to see that the model thinks our image is some images will have prediction that are accurate and other will not. Okay, the input image will first be pre-processed into an instance of a multi-dimensional array class torch.tensor. Okay, this is an RGB image, so it sounds a height, width, channel RGB. Okay, so the tensor will have 3 dimension, the color, 3 color channel RGB, and two spatial, the spatial okay image dimension of a specific size. We will get into the details of what tensor in chapter 3. Okay, but for now, think of it as being as a vector or matrix of floating point numbers. Okay, our model will take the process input image and pass it in the pretend network to obtain scores for each class. The highest score corresponds to the most likely class. According to the words, each class is then mapped one-to-one into a class level. The output is contained in a torch tensor with 1,000 elements, each representing the score association with the class. Okay, before we can do that, all that, we will need to go get the network itself, take a peek under the hood to see how it is structured and learn or how to prepare our data before that model can use it. Okay, obtaining a pretend model for image recognition. As this we will equip ourselves with a network trained on ImageNet. To do so, we will look at the Torch Vision project. Okay, Vision, which contains a few of the best performing neural network architecture for computer vision, such as AlexNet, ResNet, Inception V3. Okay, it also has easy access to dataset like ImageNet and other abilities for getting up to the speed with computer vision application in PyTorch. We will dive into some of these further along in the books. For now, let's add up and run two networks. First, AlexNet, one of the early breakthrough networks for image classification, and then a residual network, ResNet for short, which on the ImageNet classification, detection, and localization competition among other in 2015. If you don't get PyTorch up and running in the chapter, we'll get the then the design model can be found in torch model. Blah blah blah. We can look. We can take a look at actual code. Okay. The capitalized name refer to Python classes. Okay. Tunnel Alex name dense net inception resonate tunnel. The first plan that implements a number of popular models. They differ in their architecture. It is in the arrangement of the operation occurring between input and output. The lowercase names are convenience function that returns models reinstated from those classes, sometimes with different parameter sets. For instance, ResNet 101 returns an instance of ResNet with 101. Okay, 101 layers. ResNet has 80 layers. ResNet 18 has 80 layers, and so on. We'll now turn our inception attention to AlexNet. Okay, so AlexNet architecture won the 2012 okay, ILSBRC by a large margin with the top 5 best error rate. This is the correct level must be in the top 5 prediction of 15.4%. By the comparison, the second best submission, which was based on the deep neural network, till at 26.2. This was a defining moment in the history of computer vision. The moment when the community started to realize the potential of deep learning for vision tasks. That leap was followed by constant improvement with more modern architecture and running training methods, getting top 5 error rate as low as 3%. By today's standard, AlexNet is rather small into compared to state-of-the-art model, but in our case, it is perfect for taking a first peek at a neural network that does something and learning how to run a pretend vision of it on a new image. You can see the structure of AlexNet in figure 2.3. No, not that we have all the elements for understanding it now, but we can anticipate a few aspects. First, each block consists of a bunch of multiplications and additions, plus a sprinkle of other functions in the output that we'll discover in chapter 5. We'll think it as a filter of function that takes on or more images as input and produce other images as outputs. The way it does it is determined during training based on the examples it has seen on the desired output for this. Okay, 96 बाट 256 मा गरौँ रहेछ डेन्स अझ डेन्स गरे हो 386 मा सो यसमा 384 रहेछ फिल्टर लगायो कि आई थिंक 284 बाट 256 ओके डेन्सै लगायो त्यसै फ्ल्याटन गरे from left and go through 5 stack of filters is producing a number of output image. After each filter, the images are reduced in size and not read. The image produced by the last stack of filter are laid out as a 94096 element one dimension vector and classified to produce 1000 output possibilities, one for each output class. Okay, in order to run the AlexNet architecture on an input image, we can create an instance of AlexNet. It is how it is done. Okay, at this time AlexNet is an input object that can run AlexNet architecture. Actually यसको आर्किटेक्चर हेर्नुभन्दा अगाडि यसमा थियो च्याप्टर नम्बर आई थिंक च्याप्टर नम्बर पार्ट 1 को च्याप्टर 2 ओके दिस वन प्रिटेन्ड होला थियो त्यसपछि के गर्ने छ यसमा ओके टर्च भिजन इम्पोर्ट मोडेल्स गरेको थियो त्यसपछि के गर्ने छैन हैन अहिले चाहिँ यहाँसम्म पुगेको छैन नि हामी पछि हेरौँ त्यसमा AlexNet model AlexNet okay. At this point, AlexNet is an object that can be run on the AlexNet. It is not essential for us to understand the details of the architecture for now. For the time being, AlexNet is just an object that can call like a function by providing AlexNet with some previously sized output data. That is input. Okay, put connection. We run through the first set of neurons, which are will be fed in the next set of neurons all the way to the final output. For practically speaking, assuming that we have object input object of the right type, we can run the forward pass with the output is equal to LXNet input. But if we did that, we will be feeding data through the whole network to produce garbage. That is because the network is uninitialized. Its weights, the number by which inputs are added and multiplied, have not been trained on anything. The network itself is a blank or rather random slide. We'll need to either train it from scratch or load weights from prior trainings, which we will do now. To this in, let's go back to the models module. We learned that the uppercase name correspond to the classes that implement popular architecture for computer vision. The lowercase name, on the other hand, are functions that instantiate models with predefined numbers of layers and units, and optionally download the load load pretend words into them. Right? Note that there is nothing essential about using one of these function. They just make it convenient to instantiate instantiate. Pronunciation कस्तो बिग्रेको जापानिज पढ्न थाल्यो इङ्ग्लिस त बिग्रेछ त. The model with a number of layers and units that matches how the pretend networks were built. ResNet using the ResNet 101 function will now instantiate a 101 layer convolutional neural network. Just to put things in perspective, before the advent of residual networks in 2015, achieving stable law training at such rate was considered extremely hard. Residual networks pulled a trick that made it impossible, and by doing so, beat several benchmarks in one sweep that year. Let's create an instance of the network now. Collab. यसलाई रिनेम गरौँ. पार्ट 1 को च्याप्टर 2 हो त हो. I think यसलाई साइड राखौँ, त्यसपछि यसलाई राखौँ. I think यसलाई इम्पोर्ट कनेक्टेड गरौँ. कनेक्टेड गर्न सुरु गऱ्यौँ. त्यसपछि import torch vision from torch vision. Okay, from torch vision import models use गरेर छौँ. त्यसपछि यसलाई त्यसपछि कन्ट्रोल र इन्टर बनाऊ. यस पछाडि resnet is equal to models dot resnet 101. त्यसपछि यसको प्यारामिटरमा pretend is equal to pretend 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 is equal to while we are studying at the download progress, we can take a minute to appreciate that the ResNet instead of only 14.5 million parameters, that's a lot of parameters to know as a यसलाई गरियो हैन. त्यो डाउनलोड गर्नुपर्ने रहेछ. डाउनलोड गर्यो. डाउनलोडिङ हुँदै थियो, डाउनलोड भयो, 100% भइसकेछ। ओके, since we are going to speak at a resonance one, so यसमा एउटा रेसनेट लेख्ने म त। ओके, रेसनेट लेख्ने रे। ओके, सबै देखाउँछ होला यसको साइज। हो माई गड, सुरुमा कन्भर्सन न्युरल नेटवर्क लगाएर छ, त्यसपछि ब्याच नर्मलाइजेसन, त्यसपछि रिल्यु, त्यसपछि म्याक्सिमल टुडे, सिक्वेन्सियलमा फेरि बोटलनेक बनाएर कन्भर्सन न्युरल नेटवर्क, ब्याच नर्मलाइजेसन, ब्याच रिल्यु र भित्र गएर बोटलनेक कतिवटा बनाएर रहेछ। बोटलनेक पनि राम्रो, त्यही भएर 101वटा लेयर लेखाएर रहेछ। ओ माई गड। What we are seeing is modules, one per line. Note that they have nothing in common with Python modules. They are individual operations, the building block of a neural network. They are called layers in other deep learning frameworks. If we scroll down, we will see a lot of bottlenecks module repeating one after the other. One of them containing convolution and other modules. I think soundly rather. Okay. Okay, so convolution, this is okay. That's the anatomy of a typical deep neural network for counter network vision, a more or less sequential cascade of filter and non-linear function ending with a layer FC producing score for each of the 1000 output class out features. Okay, the resonate variable can be called like a function taking an input one or more images and producing an equal number of scores for each of the 1000 image net classes. Before we can do that, however, we have to pre-process the input image so they are the right size and so that their values color should roughly in the same numerical range. In order to do that, the torch vision module provides transforms which allows us to quickly define pipelines of basic preparation function. From torch vision import transformers preprocess. Okay. Preprocess is equal to torch vision dot compose torch vision import गरेको हैन र. Okay, import torch vision पनि गरौँ त. import भयो torch vision dot compose. Okay, torch transforms बाट गर्ने torch vision हान्दै छु. Transforms dot compose. So transforms dot resize गर्ने रहेछ. Resize 256. One of the best कुरा चाहिँ के लाग्छ भने मैले कपी पेस्ट चाहिँ गर्दिनँ क्या, सबै टाइप हानेर चाहिँ हेर्छु एक्चुअली. ट्रान्सफर्म सेन्टर क्रप 224 कस्तो छेकेको यार. सेन्टर क्रप ट्रान्सफर्म dot to tensor. normalize गर्नु पर्ने mean there is a 0.4585 0.456 0.406. So variance is so covariance चाहिँ 0.229 0.224 standard deviation है ना 0.225 रनान्देऊ भयो बन्यो त्यस पछाडि in this case we define a preprocessor function that will scale the image input image जुन पनि इमेज लिन्छ त्यसलाई 256 को मा रिसाइज 256 मा 256 को साइजमा रिसाइज गर्छ अनि क्रप द इमेज बाइ 24 ओके सो 56 मा लसी 24 मा क्रप गर्ने रहेछ एन्ड आफ्टर द सेन्टर around the center okay center बाट चाहिँ 254 224 मा क्रप गर्यो ट्रान्सफर्म इन्टु अ टेन्सर अफ PyTorch मल्टी डाइमेन्सनल ओके टु यो टु टेन्सरले चाहिँ ओ टेन्सरमा ट्रान्सफर्म गर्छ and in case of 3D arrow with a color height and width the normalize is RGB okay red green blue component so that they have defined means and standard deviation okay this needs to match that what was presented to the network during training if we want the network to produce meaningful answers we will go into more depth about transforms when we dive into making our own image recognition model in section 7 okay 7 3.1 section okay then पछि हेरौँ we can now grab a picture of our favorite dog say Bobby from the GitHub repo we can start by uploading image from the local file system using pillow size okay and image so from pill गर्न पर्ने हो एउटा image dog image गर्नु नि पिक्सल बाट लिदिनु त this one okay save upload एउटा फोल्डर बनाउनु पर्ने हो for the your files are saved elsewhere this runtime files will be deleted okay delete हुँदैछ भन्छ rename गरे dog.jpg राखेँ ओके dog.jpg त्यसपछि हामी के गर्छौँ भन्दा नि from pir import image so img रन गरौँ त छ ओके इन्स्टल छ so img is equal to image dot open गर्दा दिन्छ दिँदैन dog.jpg बाहिरपट्टि छ के रे jpg img dog.jpg त हो नि dog.jpg ओके रन गरे ओके इमेजले प्रिन्ट गर्यो त्यसपछि img गरेर प्रिप्रोसेस स्टार्ट ओके प्रिप्रोसेस हामीले बनाएको प्रिप्रोसेस बनाएको छौँ नि यो प्रिप्रोसेसमा चाहिँ रन हुने ओके सो यसो गर्नु पर्दो रहेछ ओके img.t इज इक्वल टु प्रोसेस गरेर हामी चाहिँ img इमेजलाई पठाइदियौँ इमेज गरेर पठाइदियौँ Save. So difference. Save changes. Sell saver. So import batch, import torch त माथि गरेन import हामीले torch भित्र मात्र गरेछ import torch भने भयो torch import torch भयो. So batch is equal to torch dot on squeeze. On squeeze ले के गर्छ भन्दाखेरि एउटा डाइमेन्सन बढाइदिन्छ. सो यसमा चाहिँ दिएको छ हामीले के एउटा यसमा दिएको छ नि imgt मा मैले चाहिँ बेसिक पाइथन बनाएको थिएँ हिजो भर्खर गरेको हौ. आई थिङ्क हिजो भर्खरकोमै छ. ओके त्यसमा छ. सो यो एन्ड डिरेक्सन ओके एन्ड m0 गर्ने चाहिँ भनेपछि एन्ड रन. सो ब्याच सो टी दिन यसलाई हेर्ने हो भने टी छ. यसो टीको सेप हेरौँ ओके 1 एउटा 1 डाइमेन्सन थप्यो. 3 भनेको कलर चाहिँ आरजीबी भयो अनि 224 मा लयो. यतिसम्म सजिलो छ. त्यसपछि अब के गर्छौँ भन्दा रेसनेट इभ्यालुएट गर्छौँ. ओके रेसनेट डट इभ्यालुएसन ओके रेसनेट इभ्यालुएसन त्यसपछि रेसनेट इभ्याल गर्दाखेरि आयो हैन. अब यसमा रन गर्ने कसरी. सो रेसनेट गरिसकेपछि आउट इज इक्वल टु रेसनेटमा सिधै पास हाल्दैन ब्याच. त्यो रेसनेटमा यो इभ्याल गर्नुको कारण के भने अटो ग्रेडलाई क्लोज गर्नलाई मतलब स्टप गर्नलाई अटो ग्रेड रन नहोस् भनेर. ओके आई थिङ्क यदि विथ रेसनेट यसरी गर्नुभन्दा त बरु यो नयाँ कन्सेप्ट आएको छ होइन. सो यसलाई यसो गर्नुको साटो यसको अगाडि चाहिँ म नयाँमा चाहिँ के गरेँ विथ टर्च डट इन्फरेन्स मोड गर्थेँ कि इन्फरेन्स मोड मा चाहिँ यसरी गर्थेँ. आउट इज इक्वल टु रेसनेट. सो ब्याच अन्डरस्कोर टी र आउट गर्थेँ. सो आउट आयो. सो टेन्सर आयो होइन. आउट टेन्सर आयो. विथ ओपन डट इमेजनेट डट टेक्स्ट. ओ कहाँ छ यो फेरि यो एकछिन यसको यो भएर हुन्छ. यसको होला नि त यसो नि त राख्यो होला नि. ओके डाटाको च्याप्टर 2 को बबी त यहीँ रहेछ. यसलाई डाउनलोड गर्नु पऱ्यो. डाउनलोड प्रोफाइल सेभ यसमा चाहिँ गएर अपलोड हान्नु त अपलोड पछि डिलिट हुन्छ भनेर छ. एकचोटि रन टाइम भयो भने त्यही पनि ओके त्यसरी के भन्दाखेरि विथ ओपन इमेजनेट इमेज के नाम थियो यार इमेजनेट क्लास टेक्स्ट एज एफ लेभल्स. पहिला सबैभन्दा पहिला त लेभल्स कस्तो छ हेर्दैम न यार. सो 1 मा 10 चाहिँ यसरी छ. 2 गर्दै 1000वटा छ होला नि त त्यति त. सो 1000 मा टोयलेट टिस्यु टोयलेट पेपर बाथरुम टिस्यु भने यसरी रहेछ. ओके सो लेभल line dot strip strip. Okay, for line in f dot read lines. Okay, done. Read line new read line. So w हैन नि त मित्र. So index is equal to torch dot max out one. कोड यो न्यू गर्नलाई के छ इन्सर्ट न्यू need control MB. So control MB गरे नि आउँछ. ओके percentage torch dot nn dot functional dot softmax रे. ओके softmax त चेन्ज भयो जस्तो लाग्छ. अझै पनि त्यसमै छ र मैले यो पुरानो भयो त छैन नि. अब डाइमेन्सन 1 मा डाइमेन्सन 1 मा 0 ले into 100 labels मा चाहिँ index 0 labels percentage where is that percentage coming from? Percentage गरिया त percentage हैन percentage कहाँ रम बोलाइएर यहाँ यतिकै बोलाएले ए percentage यही त्यही भन्दा किन रम यही percentage लेखेर चाहिँ PRR लेखेर चाहिँ तपाईको भन्नु होला. And that functional has an attribute softmax T कसरी हुन्छ यार. So golden retriever 96. Okay. Dog golden retriever मात्र साइज छ. अर्को साइज हाल्नु त हस्कीलाई. हस्कीलाई हाल्दिनु त. हस्की यहाँ भइरहेको रहेछ क्यान्सल गर्ने मोडललाई. डग वान छ हैन. डग वान कहाँ छ? डगलाई लिएको डग वान. यसले डग वान गरौँ. त्यसपछि कन्ट्रोल F10 कन्ट्रोल F10 ले हुन्छ ल. will not save. I think display JPG थियो हैन र अनि कसरी dog1.jpg control F9. So this image error PNG नुमै छ त यार. So यो फोटो हेरौँ न त्यसमा. let me check. JPG delete and home. Dog 3 राउन्ड हुन्छ कि हुँदैन त्यो पनि फेरि थाहा छैन. हुन्छ कन्ट्रोल F10 डायग्राम म्याम दुइटै छ हैन के दिन्छ त्यसले हेर्दै म त आउटपुट सो रोटेसन रिच ब्याक रहेछ रोटेसन रिच ब्याक यसो नाम म आफैलाई थाहा छैन त के हो हैन त्यो पनि यसले पत्ता लगायो हो रहेछ किन अब यसको यदि के छ मिल्दो रहेछ नि हेरेर राम्रो हैन यसो चाहिँ indices is equal to torch dot sort outlier descending is equal to true levels idx percentage idx dot item for idx in indices 0 गरेर तर टप 5 को लिनु पर्यो हैन त टप 5 को idx for idx ओके यहाँ ब्रैकेट छुट्या हो ओके ब्रैकेट छुट्या हो हेऱ्यो चाहिँ हट्ने होला नि त धेरै हट्यो होला नि त ओके 87% मिलेर रहेछ ग्रेड डिनमा 4% इभिजन हाउन्डमा 1.994% गोल्डन रिट्रिभर र भयो त सेम आउँथ्यो होला फेरि भगवान डग मात्र गोल्डन रिट्रिभर चाहिँ ल्याब्राडोर रिट्रिभर सँग मिल्दो रहेछ यो कुभाज के फ्ल्याट कोटेड रिट्रिभर रे क्लम्बर सँग मिल्छ अरे ओके यसो त टेनिस बल सँग मिल्छ नि रहेछ यसमा चाहिँ क्लम्बर सँग मिल्छ क्लम्बर स्प्यानल के हो क्लम्बर स्प्यानल कन्ट्रोल बी এখানে ओके ल्याब्राडोर यसमा मिल्छ हुन्छ त ओके होला गोल्डन रिट्रिभर ल्याब्राडोर सँग मिल्छ अरे होला we see that the first four are dogs, the third one is a breed, who know, the fifth answer tennis ball again. It's probably because there are enough pictures of tennis ball with the dog nearby, okay. So that model is essentially saying there is a 0.1% chance that I've completely misunderstood that tennis ball is okay. This is a great example of a fundamental differences in how humans and neural networks view the world as well as how easy it is for strange subtle bias to sneak into our data. Time to play. We can go ahead and interrogate our network with random image and see what it comes up with. How successful the network will be very largely depends on okay. Time to play. Okay. It's a great example of analysis. How humans and neural networks view in the world as well as how it is for strange subtle bias to sneak into our data. Time to play. We can go ahead and integrate our network with random image and see what it comes up with. How successful the network will largely depends on whether the subjects were well presented in the training set. If we present an image containing a subject outside the training set, it's quite impossible that the network will come up with a strong wrong answer with pretty high confidence. It's useful to experience moment and get a feel for how a model reacts to unseen data. Okay. We have just run our network that on our image classification of decent it learned to recognize our dog from the examples of dog together with the tons of other real object subjects. We will now see how different architectures can achieve other kind of tasks, starting with image generation. A pretend model that takes it until it makes it. Okay, okay, that takes it until it makes it. Let's suppose for a moment. Let me. We are criminals, not painters. So yes, we paint our fake Rembrandts and Picasso's, Picasso's. It quickly become apparent that they are amateur imitation rather than the real deal. Even if we spend a bunch of time practicing until we get a canvas that we can tell it's fake, trying to pass it off at the local art auction house is going to get us kicked out instantly. Even what's being told, this is clearly fake. Get out, don't doesn't help us improve. We will have to randomly try a bunch of things. Mm. So even what's being told, this is clearly fake. Get out doesn't help us improve. We will have to randomly try a bunch of. Instead, we need to find an art historian or questionable moralist standing to inspect our work and tell us what is that tipped them off the painting wasn't legit. With this feedback, we can improve our input in clear and direct way until our sketchy scholar can no longer tell our paintings from the real things. Soon we will have our Botticelli in the and their Benjamins in our pockets will be rich. So while this scenario is a bit partial, okay, let's say I'm consistent also. This I think pretend go. I think area 2.21 okay 2.21 ज्ञानको तयारी ज्ञानमा पुगेर छ ठ्याक्कै ओके अझै छ भने in the context of deep learning what we have just described is okay while the scenario is falling magic bit farcical the underlying technology sound and will likely have a profound impact on the perceived veracity of digital data in the years to come. The entire concept of photographic evidence is likely to become entirely suspect given how easy it will be automate the production of convincing a fake image and video. The only key ingredient is data. Let's see how this process works. In the context of deep learning, that what we have just described is known as game, where two networks, one acting as a painter and another as an art historian, compete to atmosphere each other at creating and detecting forgeries. GAN stands for generative adversarial adverse adversarial network, where generative means something is being created, in this case fake masterpieces, adversarial means two networks are competing to outsmart the other. And while network is pretty obvious, these networks are one of the most original outcomes of recent deep learning research. Okay. Yeah, generative. Okay, generative means okay. Okay. This okay. Remember that our overarching goal is to produce synthetic example of the class of images that cannot be recognized as when mixed in with legitimate examples. A skill examiner will have trouble determining which one is real and which are forgers. The generative network takes the role of the painter in our scenario, takes the producing realistic looking images starting from an arbitrary input. The discriminator network is a immoral art inspector needing to tell whether given image was fabricated by the generator or being in the state of real image. This two network design is atypical for most deep learning architectures, but when used to implement the GAN games, game can lead to incredible results. Figure 2.5 shows a rough picture of what's going on. The end goal for the generator is to fool the discriminator into mixing of real and fake image. The end goal for the discriminator is to find out when it is being tricked, but it also helps inform the general generator about the identifiable mistakes in the generated image. At the start, the generator produces confused eye three eyes monster that looks nothing like a Rembrandt portrait. The discriminator is easily able to distinguish the model message from the real paints, paintings. As training progresses, information flows back from the discriminator and the generator use it to improve. By the end of training, the generator is able to produce convincing fakes, and the discriminator no longer is able to tell which is which. Note that the discriminator wins or the generator wins should not be taken literally. There is no absolute tolerance between the two. However, both in networks are trained based on the outcomes of the other network. भनेपछि जेनेरेटरले चाहिँ डिस्क्रिमिनेटरबाट इनपुट लिन्छ अनि इनपुट लिन्छ अनि जेनेरेटरले नयाँ बनाउँछ अनि फेरि डिस्क्रिमिनेटरले जेनेरेटरबाट इनपुट लिन्छ नयाँ बनाउँछ त्यसलाई फेरि उहाँ बनाउँछ इट्स लाइक अ लुप बनाउँदो रहेछ ओके However, was the record trained based on the output of the networks, which drives the optimization of parameter of each network. Each technique has proven itself able to lead to generator that produce a realistic image from nothing but noise and a conditioning signal like attribute, for example, for face, young female glass on or other images. In other words, a well-trained generator learns a possible model for generating images that looks real even when examined by humans. Okay, generator. These are the noises. Generated image, real images लाई चेक गर्छ यसले हाल्छ त्यसपछि डिस्क्रिमिनेटरले चाहिँ रियल हो कि फेक हो भन्ने गराउँछ अनि डिस्क्रिमिनेट गरिसके पछाडि लुक्स लेजिट भन्छ जेनेरेटर विन्स गर्छ नभए चाहिँ फेरि इमेज दिएर फेरि कन्सेप्ट अफ गेन भन्छ फेरि एकचोटि जेनेरेटर पठाउँछ जेनेरेटरबाट साइकल गेन डिस्ट्रिब्युसन अफ द कन्सेप्ट इज द साइकल गेन चाहिँ इम्पोर्ट दियो एउटा हामीले इम्पोर्ट दियो ओके एउटा जेब्रा निकाल्यो रियल जेब्रा फेरि भएन भने चाहिँ फेरि पछाडि साइकल गरिदिने cycle can turn images of one domain into images of another domain and back. Now, without the need for us to actually provide matching pairs in the training set, we have a cycle can overflow for the task of turning a photo of a horse into a zebra and vice versa. Note that there are two separate generator networks as well as two distinct discriminators. As figure shows, the first generator learns to produce an image conforming to our target distribution zebras in the case, starting from an image leading to a different distribution horse, so that the discriminator can tell if the image produced from a horse photo is actually a genuine picture of a zebra or not. At the same time, here the cycle prefix in the acronym कति एमएल पानी छिर्छ यसमा 1 लिटर 1.5 लिटर 1 लिटर त होइन 1.5 लिटर होला कति एमएल पानी जान्छ भने 2 एमएल हो पानी कति एमएल भनेर लेखेको छ यार के भन्नु नदेखे हो लिटर हुन्छ कि as a figure shows the posture target zebra starting from the image into different distribution horse so that the discriminator cannot tell if the image produced from a horse photo is actually a genuine picture of a zebra or not. At the same time, here the cycle of the cycle prefix in the acronym comes in. The resulting fake zebra is sent through a different generator going the other way. Zebra to horse in our case to be judged by another discriminator on the other side. Creating such a cycle stabilizes the trading process considerably, which addresses one of the original issues with gains. The fun part is that at this point we don't need match horse zebra pairs as ground roads. Good luck getting them to match poses. It's enough to start from a collection of unrelated horse. And going beyond the purely supervisory. Memories of these models go even further than this. The generator learns how to selectively change the appearance of objects in the scene without supervision. About what's that? There is no signal indicating that mens are mens and legs are legs, but they are translated to something that lines up with the anatomy of the other animals. Network that turns horses into zebra. We can play with this model right now. The cycle can networks has been trained. यसलाई चाहिँ सबैभन्दा पहिला त्यसलाई क्लोज गरेर मैले फेरि discontinue and delete runtime. Okay. While they have their limits, there are hints that in near future we won't be able to tell the real from fakes in the live video feed, which opens a can of worms that we will delete close right now. Playing without pretending cycle again will give our opportunity to take a step closer and look at our network generator. In this case, generator will use our old friend resonator. We will define a resonate generator class of the screen. The code in this first cell of the 3 cycle file, but the implementation isn't relevant right now, and it's too complex to follow until we have gotten a lot more PyTorch experience. Right now, we'll focus on what it can do, rather than how it does it. Let's instant the classes with default parameters code. So cycle again. त्यो हर्समा राख्न खोजेको छ यसमा। ओके हर्समा छ। Let's pass it through processing and turn it into a properly shaped variable. So process गर्यो, batch बनायो। प्रोसेस गर्यो, ब्याच हाल्यो। आउट एउटा अनस्क्विज गर्यो, रिभर्स गर्यो, टच अनस्क्विज अनि एउटा अनस्क्विज गरेर चाहिँ एउटा डाइमेन्सनै थप्या हो। As of to be built in this, so when who write zebra this that way. If it is not perfect, but consider that is a bit unusual for the networks to find someone sort of sliding. That's about it bears repeating that the learning process has not passed through direct supervision, where humans have designated tens of thousands of horses or manually photoshopped thousands of zebra stripes. The generator has learned to produce an image that will fool the discriminator into thinking that was a zebra, and there was nothing fishy about the image. Clearly, the discriminator has never been a rodeo. Many of other funds that have already developed using adversarial training on the or other averages. Some of them are capable of creating credible human faces of non-existent individuals. Other can translate sketches into a real-looking image of imaginary landscape. Generated models are also being explored for producing real-sounding audio, credible text, and enjoyable music. It is likely that these models will be the basic of future tools that supports the creative processes. On a serious note, it is hard to overstate the implications of this kind of work. Tools like the one we just downloaded, we are going to become higher quality and more ambiguous. Face swapping technology, in particular, has gotten considerable media attention. Searching for deepfakes will turn up a plethora of example content, so though we must note that there is a non-trivial amount of not safe for our content, as such as with everything on the internet, like click carefully. So far, we have found a chance to play with the model that sees into image and the model that generates new image. We will end our tour with a model that involves one more fundamental the ingredient, natural language. Pretend network that described since in order to get first-hand experience with the model in natural language, we will use a pretend more image captioning model generously provided by Lithium Leo. It is an implementation of neural talk-to model by Andrej Karpathy. Okay, Andrej Karpathy. Yeah. When presented with a neural natural image, the kind of model generates a caption in English that describes the scene as okay, the model is trained on large data set of images along with a paired sentence description. For example, a tabby cat is leaning on a wooden table with one paw on a laser mouse and other on black laptop. This action model has two connected halves. Let us check. I think पुन्हा था chapter 1 में पुन्हा था. Mhm. Mrs. Raya building जस्तो भयो भने चाहिँ an odd looking fellow holding a pink balloon. Okay. Two connected halves. The first half of the model is a network that belongs to generate discrete numerical dimensional scene, typic guide, laser mouse bar. These are taken into input in the second half. That that generates a coherent sentence by putting this numerical description together. The two halves of the models are trained together on image captions pair. The second half of the model is called recurrent because it generates its outputs individual words in subsequent forward passes. Where the input to each forward pass includes the outputs of the previous forward pass. The neural talk to model can be found out. Okay. We can place a set of image in the data directory and run the following runs. Okay. Let's see if विभिन्न कुराहरू छ यसले त रन गरेर हेर्नुपर्छ. Lots of pretend models have been published since the early days of but until PyTorch 1 version there was no way to ensure that there would have a uniform interface to get them. Torch Hub, which is a mechanism through which authors can publish a model on GitHub with or without pretend weights and expose through interface that PyTorch understand. This makes loading a pretend model from a third party as easy as loading a PyTorch vision model. All it takes for a author to publish a model through the Torch Hub mechanism is to place on file name of configuration.py in the root directory of the GitHub repository. The file has a very simple structure. In our quest for interesting pretend models, we can now search for GitHub repositories that include Hawk.py. We'll now right away that we can load them using the torch hop.module. Let's see how this is done in practice. To do that, we will go back to Torch Vision because it provides a clean example of how to interact with the Torch Hub. Let's visit Torch Vision. This is the first entry points of the repository. We will need to exercise them later. In the case of Torch Vision, there are two ResNet 18 and 50. We already know what the returns are 18 layer and 50 layer ResNet model respectively. We also see that the entry point functions include a pretend argument if true. This model will be initialized with okay. Now we know the report that entry points and other interesting keyboard arguments. That's all. That's about all we need to load the model torch.hub without even cloning the repo. That's right. PyTorch will handle okay. So import PyTorch from torch input hub. Instead model hub.model PyTorch master order. This one is to download a snapshots of the master branch of the PyTorch Vision repo along with the weights to a local directory. Conclusion, okay. We hope this is Which way optimized to carry out the more enterprising of was already put one of the model behind as server and start business sharing of profits with our original authors. Once we learn how these models are built, we'll also be able to use the knowledge we gain here to download a pre-trained model and quickly fine tune it in a slightly different task. We will also see how building blocks that deals with different problems or different kind of data can be done using the same building block. One thing that PyTorch does particularly right is providing this building block in the form of an essential toolset. PyTorch is not a very large library from an API perspective, especially when compared with other deep learning networks. And this book does not focus on going through the complete PyTorch API or reviewing deep learning architecture. Rather than we will build hand-on knowledge on these building blocks. In this way, you will be able to consume the excellent online documentation and repositories on the top of the solid foundation. Starting with the next chapter, we will embark on the journey that will enable us to teach our computer skills like those described in this chapter from scratch using fighters. We'll also learn that starting from a pretend network and fine-tuning it will on new data without starting from scratch is an effective way to solve problems when the data points we have are not particularly numerous. This is one for the reasons pretend networks are an important tool for deep learning, but practitioners to have time to learn about the first fundamental building blocks tensor. Exercise the Garena pretend network is a model that has already been trained on a dataset. Such networks can ideally produce useful results immediately after loading the image parameters. By learning how to use the pretend models, we can integrate a neural networks into our project without having to design or train it. RxNet are two deep neural networks, convolutional neural network that set new benchmark for image recognition in the years. They were really generative adversarial networks have to parse the data and the distributor that work together to produce output indistinguishable from authentic one. So CycleGAN is the architecture that supports converting back and forth between two different classes of image. Neural talk to uses a hybrid model architecture to convey an image and produce a text description of the image. Torch Lab is a standard way to make models and work from any projects with appropriate hop configuration.py file. सो आजलाई चाहिँ यति गरौँ, अहिलेको लागि चाहिँ यति गरौँ, मेबी बेलुका पनि आउन सक्छु, तर चाहिँ आई थिङ्क बेलुका पनि पढ्नु पर्ला फेरि च्याप्टर 1 र 2 कम्पेयर गऱ्यो 3मा चाहिँ आई थिङ्क म टेन्सरहरूको कुरा रहेछ ल अब 3मा आउँछु फेरि पछि आउँला है फेरि पछि पढ्छु माता नै